Hi friends, in the last session we were discussing about some shortfalls with single linked list. Now what is it? So let's just look at how to delete a node having data which is equal to 3. So the process is start from first node, then step by step move forward till reach the correct node. So what are these? So let me call this node 1, node 2, node 3 and node 4. Here we have placed address of node 2. Here we have placed address of node 3 and here we have placed address of node 4, and node 4 being the last one, we don't have anything to write, so it's a null is written here, which tells that there is no more nodes are available after this. That's end of it. Symbolically we can also represent it in this way, saying that that's end of the list, so no more nodes available after this. Okay, so what we do, so let's just do manually first and try to see how this works out. Okay, what is that? We go to first node of A. Done. So we are here, so that means we go to N1. Check data of N1 is equal to 3. So the answer is no, because data of N1 is 1. Okay, what next? Then go to next node. How to go? Yes, the next of the next node is there. So using this N2, which is address of the next node is written. So here this is our data component and this is our next component. Here we have written address of the node where the N2 is saved. Okay, so we go to N2. Okay, then next is we go to N2 and then check whether data in node 2 is 3, and the answer is again no. Then what? Go to next node. What is that next node? It is written here, which is N3. Then go to N3, then check data of n3 is equal to 3. Data of n3 is equal to 3. And the answer is yes. So what next? What is asked? To delete this node. So this node has to be deleted. And as we discussed in our previous case, so just to delete node 3, n3 is to delete n3, the steps we have to take is n2's address. So next of n2, we make it equal to n3. So yes, it was already n3. Now we have to make it n4. So next of n2, in place of ampersand n3, we should write ampersand n4. That means it directly jumps next time to this location instead of this. So because we have here ampersand n4. So we, in the next time when you are searching for something, then you look at this node. If this is not what you are looking for, then look at who is next. It is n2. Go to n2. If this is not what you are looking for, then next, what is next? Next is n4. It directly goes to n4. So in future, this will never come into picture because after n2, it directly linked to n4. So that's as simple as that. So just this one line will solve the problem. Done. So is it that simple? Of course not. Why? Now, how did you know that n2 comes before n3? Yeah, you may ask, what is nonsense questions? We have started from the beginning and went to n1, then gone to n2. After that, we have gone to n3. So we have gone already to n2. And then we have gone to n3. Fine. But when you are in n3, how do you know that you have come from n2? Because in the node, it only says what is data and where to go next. But nowhere it is written from where we came here. So this question has no answer in our data structure in the single linked list. So now the question is, does that mean that we can't delete a node? Of course, we can delete a node, but only thing now is we need to do an extra work. What's that extra work? We need to maintain two pointers. What is the current node? What is the previous node? Okay, so we begin with our first one. So when we are beginning with first one, we don't know where we came from. So we don't know where we came from, but we know where we are. We are at n1. Done. At n1, we do this checking. and then realize that this is not the node we wanted, and we need to go to the next one. So when we go to next one, yes, it is very simple. We were at N1, we wanted to go to next one. So the address of next one is already known. So using that, we go to N2. Now we need to remember from where we have come. So we put that in the previous. In that, we don't know where our data is. What is our data? In N2, it is not what we wanted. So we move on to the next one. We go to N3, and this N2 we copy in our previous. And when we reached N3, yes, we found it. And now you want to write next of N2 should be N4. So this we can write as next. What is N2? N2 is saved in the previous. Is N4. What is N4? N4, we can simply say the next of current. So next of current should be made next of previous. So this was current, this was previous, and this was our next. So we wanted to remove this, therefore we looked at what is previous. Previous is N2. In N2's next position, we write what is there in the next position of current. So next of previous is made equal to next of current. That's only means trying to say that this ampersand N4 is copied into this. So after copying N4 into this, what happens is you start from A, go to N1, then go to N2. After that, it directly takes you to N4. So that way, N3 will be nowhere in the picture. Yeah, we need to do this additional circus. So this is one way of doing it. Other way is you may want both direction activity, so moving forward as well as backward. So we may require forward as well as backward movement as we did. This is only one way, forward movement. So we may wish to have both forward as well as backward movement, and that we can solve using a doubly linked list. So there we come to the next data structure we wanted, and that's doubly linked list. And this is going to solve many of our problems, including this particular problem. So what doubly linked list is, how it is implemented, and how it is going to be useful in our activities. So that's the issue we need to look at in our next session. So keep watching. Thank you.